For section 5.1, we are going over linear functions. This should be a review from last year. So our first example, given the equation of a line in slope-intercept form, that means we have the slope and the y-intercept. I can identify the slope and y-intercept. So I look at A, here's my slope. The slope is -7. And then the y-intercept, depending on if they want it as a point or just a number, your y-intercept is at 1. And if they want it as a point, x is at 0 and the y-intercept is at 1. So it just depends on the formatting. Usually they want it as a point. So for B, I look at my slope. That number that would be in front is a +1. And then the y-intercept is -5. So if I write it as a point, x is a 0 and y, for the y-intercept, is -5. Question C, slope is 2/3 and the y-intercept is -3. So when I write it as a point, it would be 0 for x and the y is -3. Next question, given 2 points, find the slope, also known as the average rate of change. If you remember, slope is y minus y over x minus x. Slope formula. So I have x, y, x, y. Y goes on top, x is on the bottom. Y goes on top, x is on the bottom. I then need to put in my subtraction signs from my formula. That becomes a 4 plus 2, right, because the double negatives. And that stays a -2 minus 5. 4 plus 2 is 6. -2 minus 5 is -7. And that will not reduce. So for question B, I have x, y, x, y. There's my fraction. Y goes on top, x on the bottom. Y goes on top, x on the bottom. I put my subtraction signs in. 3 minus 8 is on top. Double negatives become a plus. 3 minus 8, 8, 7, 6, 5. That'd be a -5 over 7, 8, 9, 10, 11. -5 over 11. And those are our slopes. If you can reduce it, you can check with your calculators. Like if I have the fraction 6 over -7, that won't reduce. Your calculator, you can check your work if you want. Yeah. Example 3. Given the graph of a line below, identify their slope and y-intercept. Create an equation in point slope and in slope intercept form to represent each line graphed below. All right, so starting with slope. That is rise over run. So I have a point here, an intersection, intersection. These are also called lattice points, wherever they intersect at whole numbers. So my slope is going down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, which is really just a -3. There's our slope. Y-intercept is at 0 comma, -2. Right there. That's our y-intercept on the y-axis. Oh, I don't know why I put -2. That is a +2. Sorry about that. Okay, from there, I can then plug in. So, if they want point slope form, that would be x1 plus y1. Okay. I would write y equals my slope. Then I would do x minus 0 with a +2 at the end. That would be point slope form. If they wanted slope intercept form, that's y equals mx plus b. Y equals my slope, and then the intercept was a +2. These equations represent the same line, this line right here. They both are a representation of that line. Okay, question B. I'm looking for lattice points, those intersections that are on whole numbers, right? I don't want to mark anything that's a decimal. So then my slope is going up 1 over 4. Up 1 over 4. That's a positive slope. And that won't reduce or change. The y-intercept is right down here at 0, -3. So if I use that to write point slope form, y equals my slope, x, then I'd put -0. Outside, I'd put a -3. So they kind of fall into place in our equation. And then same thing for slope intercept form. Y equals my slope, x, and then my y-intercept was -3. Example 4. Write the equation of a line in point slope form. Point slope form, which is this formula right here, using the given information. So I would write y equals 1/4 x. This will become, see how there's a negative in here? Double negatives will make it into a +3. And then you won't change the sign on the y. That one will stay the same sign. So for question B, y equals, my slope is a -2, x, this was a +6, so that would be -6 in my parentheses, and this is a +10. It will stay the same. Example 5, write the equation of a line in point slope form using the given information. Okay, so we're doing the same equation again. But they didn't give me the slope, so they are being sneaky. I need to find the slope first. x, y, x, y. Y goes on top, x on the bottom. Y goes on top, x on the bottom, and then I put my minus signs in. And I'm going to be a little bit lazy, and negative 18 minus a negative 2, negative 10 minus 17. And I did not type a 10. 17, okay? Checking signs, 16 over 27. 16 over 27 is our slope. And then I have these 2 points. So depending on which point I pick, I know that m equals 16 over 27, and I'm just gonna use the first point, right? You can use either one, but I'm just gonna use the first point. Negative 10 comma negative 18. And I'm gonna plug it in to my equation. Y equals 16 over 27. X, this becomes a plus 10, and this stays a minus 18. And this is called point slope form, because it has a point and a slope in its form. All right, let's try B. X, Y, X, Y. Y goes on top, X on the bottom. Y on top, X on the bottom, put my minus signs in. 13 plus 14, that'd be 4, 5, 6, 7, 27 over 5 minus 6. 5 minus 6 is negative 1. When I reduce that, that's negative 27. Okay, from there, I know that is my slope. I'm going to use the first point. And when I plug in, y equals negative 27, x, this positive 5 is going to become a minus 5, and 13 will stay a positive 13. Point slope form. All right, example 6. Find the equation of a line passing through the given points. Write your equation in point slope form. Oh, point slope form and slope intercept form. Okay, these ones are my favorite. First, we find the slope, because we're only given 2 points. So xy, xy. Y on top, x on the bottom. Y on top, x on the bottom. The minus signs go in. 5 minus 15, negative 10. 8 minus 3, 8, 7, 6, 5. That's a 5. That gives us a negative 2. That is our slope. Alright, so if I know my slope, I can then build point slope form by plugging in negative 2, x minus 8 plus the 5. Okay, there is point slope form, so we can check that off. We found that one. Now for slope intercept form. This is the one that's a little weird. I'm going to distribute the negative 2 through. That would become a negative 2x. Negative 2 times negative 8 makes a plus 16. And then this plus 5 is floating out here on its own. Do not multiply it. You only multiply the negative 2 into the parentheses. Then you combine like terms. Negative 2x plus 16 plus 5 is 21. And that is slope-intercept form. Okay, let's try that on B. So we're first going to find slope. Y goes on top, x on the bottom. Y on top, x on the bottom, put my minus signs in. 10 plus 5, 15. Negative 8 minus 7, 8, 9, 10, 11, 12. Negative 15. That gives us a negative 1. I then have my point, negative 8, 10, and I'm going to plug those in. Negative 1, x, plus 8, with a plus 10. Then I am going to distribute. That would make a negative 1x. That would make a minus 8. And I have a plus 10 that's on the outside. I combine my two last terms together. And negative 8 plus 10 makes a plus 2. So we have our point slope, slope-intercept. Our last example is graphing linear equations. If you have a TI 30XS, you can build tables. That's pretty nice. You would just click table, clear, and you would type in negative 3 with the variable x plus 5. And then push enter, 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 bunch of enters, and then you can scroll through and build a table. So 0 is at 5. 1 is at 2. 2 is at negative 1. Okay? So you can build tables with the TI 30XS multi-view. If your calculator doesn't have that function, basically you're going to just do negative 3, plug a 0 in, plus 5. 0 is at 5. Negative 3, plug a 1 in. 1 is at 2. Plug a 2 in. 2 is at negative 1. You can build a table just by plugging numbers in. Then you would click those points. 0 is at 5, 1 is at 2, and 2 is down 1. And it will fill in the line. All right, question B. These ones are my favorite because you do not have to use your calculator at all. Basically, it says x is negative 3. That means all of these x's have to be negative 3's. X cannot be anything else. It has to be negative 3. Y's, on the other hand, you can pick. I can pick any number I want. 0, 1, 2. I can pick a 5. I can pick a 7. I can pick anything for Y, but X has to be a negative 3. Negative 3 zeros here. Negative 3 up 1. This is called a vertical line. And it hits the x, where x is negative 3. That's why it's x equals negative 3. Question C, 4 over 5x plus 1. You may make a table on your calculator. I am going to plug in And with fractions, see how I have 4 over 5? If I want to get rid of that fraction, easy way to do that, times it by 0. If I times it by 0, it goes away. I'm left with 1. Okay. Now, another way to deal with fractions, if I don't want that fraction there, I can times it by the denominator. I can plug a 5 in. 5 is at 5. Okay. The other option, if I want to get rid of a 5, I can do a negative 5. That would also cancel out the 5. Negative 5 is at negative 3. So we're using whole numbers. When we're graphing these, it's easier to graph the whole numbers. 5 is up 5. Negative 5 is down 1, 2, 3. There are other shortcuts to graph these. Feel free to use them. Don't feel like you have to plug in. Okay, next one, x, y. I have 1/2 with an x. I'm going to get rid of it with a 0. Then I'm going to plug in, I don't want the fraction, so I'm going to plug a 2 in. And same thing, I don't want a fraction, so I'm going to plug a negative 2 in. And I can graph my points. 0, 0, 2's up 1, negative 2 is down 1. And there's my graph. Last one. This is another one of my favorites. When it says f of x, it is the same thing as saying y equals negative 2. F of x is function notation, and then the y, same thing. So don't panic when you see f of x. Just remind yourself, okay, they're telling me that y equals negative 2. So when I build my table, y has to be negative 2's. The x's can be whatever they want. So I could pick a 3, 4, and a 5. I could pick a 7. I could pick a negative number. X's can be whatever they want, but y has to be a negative 2. 3 is negative 2. 4, negative 2, 5, negative 2. This is called a horizontal line. And the reason it hits y, when I draw this line, it hits negative 2 on the y-axis. Y is negative 2.